Hello everyone, and welcome to our 7.2 notes, Properties of Parallelograms. So first, what is a parallelogram? Well, there's going to be a word that stands out to you that we have heard before and that we've talked about a lot. Parallelogram is a quadrilateral, so remember that a quadrilateral has four sides. It's a four-sided figure, and it has both pairs of opposite sides parallel. Okay? And there are going to be 5 properties we talk about of a parallelogram, and that's actually going to be my very first property. Both pairs of opposite sides are parallel. That is, by definition, what makes it a parallelogram. And so we mark that with our little arrows. These are parallel. So we'd say that PQ is parallel to NR. And then these are parallel, PN and QR. So, and PN is also parallel to QR. Okay? While both sides are opposite sides are parallel, we also know that they're going to be congruent as well. So I'm going to mark that. P to Q, the distance from P to Q is going to be the same as the distance from N to R. So P to Q is going to be congruent to N to R. We also know that P to N is going to be congruent to Q to R. So P to N is congruent to QR. Okay. All right, so those are my very first 2 properties. We know that opposite sides are parallel to each other and opposite sides are also congruent to each other. Okay. Another property that we know is that the both pairs of opposite blank are congruent. So that's going to be angles. We're doing something in class that will kind of let you discover this and notice these things on your own. And so when I name these, I need to make sure I'm naming the full angle. So I'm not just going to call this angle P. Since I have multiple angles happening over there, I'm going to call this angle NPQ. So angle NPQ is going to be opposite to angle, this one right here, which is QRN. QRN. So those are going to be congruent to each other, as well as these opposite angles at N and at Q. So I'm going to name those. I'm going to name that PNR. Angle PNR is going to be congruent to angle PQR. So opposite angles are congruent to each other. So we're just marking these properties into the picture. And then last but not least, we know that both of the diagonals are going to bisect each other. Remember that bisect means to cut in half. So that means that this point S, where they cross, N to S is going to be congruent to S to Q. N to S is going to be congruent to SQ. That diagonal gets bisected, and the other diagonal gets bisected as well. So I'm going to do 4 marks on here to show that it's different. 1, 2, 3, 4. Okay, so we also know that R to S is going to be congruent to S to P. So we have those congruent pieces because those diagonals bisect each other. All right, the very last one says that we know that consecutive angles are what to each other. So we know consecutive means next to each other. And so like consecutive letters of the alphabet are like B and C, C and D next to each other. And so consecutive in this picture would be like these 2. Those are next to each other. These 2 are next to each other. These 2 are next to each other. And then we have these 2 are next to each other. So we know that they're not congruent because they're not marked as congruent. The opposite angles are congruent. So consecutive angles are going to be supplementary. And y'all are going to discover all of this in class through our activity. So if you were not here today, ask me and I can give you a link to that discovery. So they're going to be supplementary to each other. So what are consecutive angles are going to be supplementary? Which angles is that? That's going to be angle N and angle P. N and P would be consecutive angles are going to be supplementary. N and P are going to be supplementary. P and Q. Q and R. Angle R. And then N and R. And so how I like to match that in the picture is I like to just say, okay, these are always going to add up to 180. Let's think about why that makes sense. Why would it make sense for these to add up to 180? If these are parallel lines, which they are, then these angles would be same side interior. And same side interior angles in these parallel lines, if I were to extend this, same side interior angles are always going to be supplementary. They add up to 180 degrees. Okay? And so since those lines are parallel, that is what creates this supplementary relationship. All right, it says if QMPR is a parallelogram, so we've got our picture, QMPR is the parallelogram, complete the following statements. Who is going to be congruent to angle MPR? So I like to highlight this. MPR is this angle right here. So who is going to be congruent to that? It's opposite angle, and so we call that angle MQR. Angle MQR. So I'm going to erase as I go just so that I can make the marking on the picture and it doesn't get too busy. What side length is going to be congruent to PR? PR is going to be congruent to its opposite side, MK. MK. Let's keep going. Let's see what it asks about next. Next, it asks about another angle, so we have to find where that angle is. M to P to K. M to P to K. That is this one right here, MPK. So who is going to be congruent to MPK? That is going to be our alternate interior angle, is going to be this one right here. Alternate interior angles, if that is our parallel lines, and we've got our transversal happening, that is going to be R to K to P. Alternate interior angles. So all of those things we learned about with parallel lines still hold true here. Okay, I'm just going to keep going and erasing it as we go. PRK, who's going to be congruent to angle PRK? PRK is this full angle, so it's going to be congruent to its opposite angle, which is KMP. KMP. All right. Now we want to know which side is parallel to something. So which side is parallel to PM? PM is this side length right here. It's going to be congruent to its opposite side, RK. It's going to be RK. Who is going to be congruent to angle MTK? That's this one right here. That is an angle on the inside of this shape. It's going to be its vertical angle, PTR. P to T to R. You can see how this picture gets crowded very, very fast. So we're going to just keep changing colors and keep erasing. M to T, what side length is going to be congruent to this little segment right here, M to T? That's part of the diagonal. And remember that the diagonals bisect each other, so it's going to be the rest of that side, because point T is going to be the midpoint of that segment, and this gets bisected. So we'd say TR. Then it wants to know who is parallel to MK. Here's MK, so who's parallel to that, facing the same way? Its opposite side is PR. So those are parallel to each other. P to R. And then what do MKR and PRK add up to? So let's go find those in the picture. MKR is this one right here. What is that one? And then this one, PRK, there's a lot of letters going on. What do those add up to? Well, those are consecutive. Those are next to each other. So they're not congruent, but they are supplementary. So they're going to add up to 180 degrees. 180 degrees. Okay? So this is, we asked a whole bunch of letters going on. We asked a whole bunch of different questions just to test your knowledge of these 5 properties from a parallelogram. All right, this next section says to solve for the indicated values for the parallelograms. And I needed to add that for the parallelograms part because we do not have parallel markings. And if we're going to use the properties of parallelograms, we have to know for sure that these next 9 problems are parallelograms. So what you're going to do is you're going to go to each problem and see what information is listed. Like in number 1, 2, and 3, I have information about the angles, whereas in number 4, I have information about the sides. 5, I have information about the diagonals, and that's going to tell you which property to use every time. So the first thing we need to see is, we have 2 properties that go with angles of a parallelogram. Opposite angles are congruent and consecutive angles are supplementary. So the ones that are opposite to each other, which is what it is in the picture, those are going to be congruent to each other. So I know that 11A is going to be equal to 110. So then you would divide by 11 on both sides and you would get 10 for A. A has to be 10 for both of those angles to be congruent. Number 2, instead of these being opposite angles, they're sitting next to each other. So these are consecutive. What do we know about the consecutive angles in a parallelogram? Well, these are same side interior angles. So they're going to add up to 180 degrees. So x plus 115 equals 180. And you would subtract 115 from both sides, and you would get 65 degrees. So this yellow angle has to be 65 degrees. It's supplementary to 115. All right, number 3 is a little bit harder because we have 3 different things listed. Here's our opposite angles in yellow. And right now I can't set y equal to 7x because those are 2 different variables. But if I can find x, then I'll know what y is. Okay? And so what we're going to do is we're going to work with the ones that are both x's. So which ones are both x's? These 2, and those are consecutive. So consecutive angles add up to 180 degrees. So 8x plus 7x equals 180. And then 8x and 7x is going to be equal to 15x, and that equals 180. So when we divide by 15 on both sides, we find out what x is, and x is 12. X is 12. So why does knowing that help me? Because now I can actually find out what this yellow angle is. That's going to be 7 times 12. So 7 times 12 is going to give me 84 degrees. So if this yellow angle is 84 degrees, its opposite angle is also going to be 84 degrees. 84 degrees. I also, if I had wanted to, could have plugged that into the pink angle and then used the fact that those add up to 180, but it's easier to work with the opposite angles. Okay, let's look at number 4. Number 4 is working with given side lengths. So we know the opposite sides are congruent in a parallelogram, so these pink ones are equal, and then these blue ones are equal. And so we want to solve for x and we want to solve for y. So what do I set equal to 3x plus 1? That's going to be equal to the opposite side of 5x minus 1. So those two pieces are going to be equal to each other. And so we'd get our variables on the same side, and we'd get 1 equals 2x minus 1. We're going to add 1 to both sides, and we get 2 equals 2x. So then x is equal to 1. So my value of x is 1. You could always go back and plug that in and check it. 3 times 1 plus 1 is going to be 4, and then 5 times 1 minus 1 is also going to give me 4. So I know I did it right. For my pink opposite angles, or opposite sides, for my pink opposite sides, I'm going to set 2y minus 9 equal to y minus 2. I'm going to put a 1 here just so that it helps me move this over. Minus 1y minus 1y. We get y minus 9 equals negative 2, and then we add 9 to both sides. So we get a value of 7 for y. Let's check that. 2 times 7 minus 9, that's going to be 14 minus 9, which is 5, and then 7 minus 2 gives me 5 as well. Okay, so we're just checking our work, just making sure that we did it right. All right, on number 5, this fits the property that the diagonals of a parallelogram bisect each other, meaning this blue diagonal and this pink diagonal intersect at this point, and it's the midpoint. And then we know that the blue pieces are equal to each other, and we know that the pink pieces are equal to each other. So I'm going to set 4x minus 2 equal to x plus 10. Those pieces are equal. And so I'm going to move the variables to the same side. Minus 1x. We get 3x minus 2 equals 10. And then we move the 2 over. We get 3x equals 12. And we divide by 3 on both sides. And the value of x should be 4. Let's plug that in. 4 times 4 is 16. 16 minus 2 is 14. 4 plus 10 is also 14. So I know that I did some good math there. Okay. Who is going to be equal to the left half of the pink diagonal, y plus 5? That is going to be equal to 3y minus 1. So we're going to get our variables on the same side. We're going to add 1 to both sides. We're going to subtract 1y from both sides. We get 2y equals 6. So y is going to have a value of 3. Let's check ourselves, make sure we did that correctly. 3 plus 5 is 8, and then 3 times 3 is 9 minus 1 is also going to give me 8. Okay, so I know that I did, those diagonals do bisect each other for the values that I found. All right, number 6. Now number 6 is interesting because it's got a side length, but it's also got angles. So let's do one thing at a time. Our side lengths, those are opposite sides, so those are going to be equal to each other. 3x plus 3 is going to be equal to 6x minus 18. So we're going to get our variables on the same side. We're going to move the 18 over, and we get 3x equals 21, so x should be 7. Go back and plug that in. 3 times 7 is 21, plus 3 is 24. 6 times 7 is 42, minus 18 is going to give me the exact same thing. Okay, so what else is on there? What else is listed? It's pointing here at this angle and here at this angle. Those are alternate interior angles in a parallelogram. Since those are alternate interior angles, we know that alternate interior angles are equal to each other. So we can set 7y minus 3 equal to 2x plus 4, and then we would just solve. So we would get 5x equals 7, alternate interior. Here we go. Is that an x? Oh, that's a y, y'all. Hold on one second. This is a y. I knew I did something wrong. So 7y minus 23, or minus 3 is equal to 2x plus 4. Here's the problem. We've got two different variables. We've got a y here and we've got an x here. But we just found what x was. What is x? X is 7. So I can plug in a 7 in here. X is equal to 7. So 2 times 7 is going to be 14 plus 4 is 18. So we have 7y minus 3 equals 18. So we actually had to go through and plug that in. So we add 3 to both sides and we get 21. So y is going to have a value of 3. Y has a value of 3 for those alternate interior angles. If those were both y's, we would have just set them equal and solved, but because one of them was an x, we had to go plug in our value from x. So you had to solve for x before you solved for y. All right, this next one, we want to find angle 1, angle 2, and angle 3. So the easiest thing to do is find its opposite first. So what is opposite to 79? Angle 2, so that is also going to be 79 degrees. How do I find the other ones? Well, these are going to be consecutive. Angle 1 and 79 are next to each other, so those add up to 180 in a parallelogram. So what is 180 minus 79? That's going to give me 101 degrees for angle 1. And then if angle 1 is 101 degrees, that means angle 3 in the picture is going to be 101 degrees as well, because those are opposite angles. 101 degrees and 101 degrees. All right, number 8 is more angles. So immediately I know the opposite angles are equal to each other. So if this is 113, angle 1 has to be 113 as well. This part is a little bit harder. We know that this is 22 and then this is 45. So one is obviously bigger than the other one. So we're gonna go alternate interior. So who's gonna be alternate interior to the yellow one? It's gonna be number 3. Those are alternate interior angles, so those should be congruent. So angle 3 is 22 degrees. And then if this is 45, the purple angle, its alternate interior angle is going to be this one. So angle 2 is also going to be 45 degrees. All right, last one, more angles. So we've got a parallelogram, and I want to find my angle 2, 1, and 3. So where do I look? Let's see what we can solve for first. Angle 1 and angle 3 are going to be congruent because those are alternate interior angles. But unfortunately, I don't know either of those. So what we're going to do is we're going to have to solve for angle 2 first. Angle 2 is sitting not vertically, but in a linear pair with 78 degrees. We know that that should add up to 180. So 180 minus 78 is going to give me 102 degrees for angle 2. 102 degrees. So what we want to do now is we want to copy across. If that's 102, its vertical angle is 102. If this is 78, this piece right here, just this green piece is 78, this vertical angle is going to be 78. Why does that help me? Because in this parallelogram, this is a triangle. And we know that the interior angle sum of a triangle is 180. So to find angle 3 is going to be equal to 180 minus 78 minus 48. And what we get when we do that is 54 degrees. And if angle 3 is 54 degrees, then angle 1 is also going to be 54 degrees. So your assignment is on the back. This is your 7.2 homework. So try those problems and then we will check it tomorrow.